Okay, looking at data, imagine that we had a set of numbers, just say some random numbers like these. Okay, set of numbers there. If we want to find information and analyse those numbers, maybe find the mean, the median, the mode, the range, before we do that we have to put them in order. So from smallest to biggest, just rewriting them. Okay, so there we've got our scores. If I want the median is the middle number of a set of scores. I could go along and cross out all the scores, but there's 10 scores there. So if 5 are there and 5 are there, then the median is in the middle of those two. But because those two are both 3s, then the median is 3. The mode is the most common score. So have a look there. Which one's the most? There's 3 1s, so the mode is 1 because it occurs the most. The range is the biggest score. Take away the smaller score. So there is a range of 5 scores. For the mean, this is the one where we have to do a few calculations. We have to add up all those scores that are there and divide by how many are there. We know there's 10 scores, so we divide by 10. If I add up all those scores, I think we get 30. And 30 divided by 10 is 3. So the mean of those scores is 3. Now you have to think about your answer you get. If the scores are from 1 to 6, then your mean has to be somewhere between 1 and 6. Now, if I wanted to put those scores into a frequency histogram and polygon, although I should be using a ruler, I need my axes, I need the scores across the bottom, and so the scores we have are 1, 2, 3, 4, 5, and 6. And we have a frequency up the side. So here are the scores down here, so I should put that down there. We have frequency up the side, and these ones, it only has to go up to 3 because that's the most of any of the scores. Okay, and then my columns straddle those numbers. So because there are 3 1s, my first column goes there. Then there are there's only 1 2. Then there are 2 3s. And then there are 2 4s. There's only 1 5 and 1 6. Realising that I should be using a ruler and all the columns should be the same width. Then to put on my polygon, it starts in the corner down there, and then the middle of each of the columns, and then I join them up with straight lines and a ruler. Cross, and it should end out there. So that's my frequency polygon is the red line, and the frequency histogram are the columns. And I've got my titles on both axes there. Now if I wanted to draw a cumulative frequency histogram, it's almost the same, except this time the frequency is like a running total. So because there are 10 scores, that's why I have to go up to 10. Now once again, I should have used a ruler because it may affect my median. But anyway, let's have a look. There are 3 1s, so I have to go up to 3 for the column of 1. Then there's 1 2, so I go 1 more than the column for the 1s. Then there's 2 3, so from this column I go up 2 more. So you can see the column's getting bigger and bigger. And then for 4, there's 2 4s, so I have to go up 2 more. So that's about there. Then there's 1 5, so I'll go up 1 more. And then there's 1 6, so I go up 1 more. So it keeps getting bigger. Then I can draw the cumulative frequency polygon. which goes to the corners. Now, once again, must use a ruler, because what happens next might get affected if I haven't got nice straight lines. Okay, if I want to find the median, because there's 10 scores, I find halfway, which is 5, which is here. With a ruler, I go across until I hit that red line, and then I drop down. Where it drops down to is the 3. So the median for these scores is a 3. Now, if it drops down into any of the columns, it is that number. The only time it changes is if, when we went across, if we hit there and we are on a line, that's the only time the score would be between 3 and 4, so it would be 3.5. So this is for single scores like this. Just writing out those scores again. This time, I might want to draw a box and whisker plot for those scores. Now, for a box and whisker plot, we need to find 3 medians, if you like. We need to find the middle of all the scores. So before that was in here, and we call that Q2. So that's the median, and it happened to be 3. Then we look at the scores left over at this end, and we find the middle of those scores, which happens to be a 1. And then we go up this end and find the middle of those scores, which happens to be a 4. This one's called Q1, and this one's called Q3. So when I draw a box and whisker plot, once again, I should have a ruler. I have to have all my scores from 1 to 6 nicely spread out. Then the whiskers go all the way from, or start at 1 and finish at 6. But let's have a look. Our box has to start at Q1, so at 1. So the box starts there. It ends at Q3, which is at 4. And that's where the box is. And the line in the box is at 3. Now the whisker has to go all the way out to 6. And normally it would go out this side, except the first score is a 1. So there is actually no whisker. So that's what it looks like. Now, what this means is 25% of the scores are in there, 25% of the scores are in there, 25% of the scores are there, and 25% of the scores are there. So box and whisker plot can help you find the percentage of scores and where they lie. I could represent those same scores in a dot plot. So say, for example, I wanted the 1s. So there's a 1 there, 1 there, 1 there. So there's 3 1s, 1 2, 2 3s, 2 4s, a 5 and a 6. So that's what it would look like as a dot plot. There's also a way to write the scores, and that's a stem and leaf graph. We normally use it for numbers over 10. So say, for example, if I had, I'm just going to write this. So if I was to write that, that would be the number 30. And then if I had that, that would be 32, 33, 45, 48, 49, 52 and 57. And then we can do the same sort of thing that we would normally do, finding the median, the mean. But if you think about it, you could write the scores out. So there's a 30, a 32, a 33, 45 and so on. So you could write them out and then have a look at what your scores are. That's up to you. Then we have different shapes of distributions. If, for example, with the dot plot, we had some scores that look like this, you can see it's pretty even if I drew over the scores. Okay, that's a normal distribution. But if I had a few scores like this, and all the scores were up the bigger end, if I was to draw around that, okay, it's almost like a skewer. It's pointing in the negative direction. So this is actually called negatively skewed. But then if I had scores where I had lots down this end and not much down there, then my skewer would point the other way, and that one is, it's pointing in the positive direction, so it is positively skewed. And if I had something like this, I'm just using a dot plot because it's easy to plot, but if you had, the same with any numbers, okay? This guy down here, he's out by himself. He's called an outlier because he's lying away from where the other scores are. Next, we can have a look at the frequency distribution table. This is a table. This first column's got the scores. I've only got scores 3, 4, 5 and 6. Let's say I've got 2 3s, 1 4, 6 5s and 5 6s. Sometimes this column here will be an fx column, which means you times the f with the x. So the frequency and the score. So 3 2s are 6, 4 1s are 4, 5 6s are 30 and 6 5s are 30. Now these two boxes down the bottom here are for the totals of those columns. So the frequency, so 2 plus 1 is 3, 9, 14. So there's 14 scores all up. And if I add the next column, 30, 60 is 70. Now what that does for us is allows us to find the mean without having to write all those out. So it's how the scores added up divided by how many scores there are. And that happens to be 5. So the mean of these scores is 5. Now sometimes you might be asked to put a different column at the end. And this is called the CF column, the cumulative frequency column. So that's where you have a running total of the frequencies. So 2 would go there, but then we have to go up and add 1 to it. So that would be 3. Then we add 6 to it to get 9. Then add 5 to get 14. This number here should be the same as that number there. And this column would help if you had to draw a cumulative frequency histogram. And I think that's all you would need to know for data.